C. Standard 12th Max, Chapter 6, Applications of Vector Algebra, Exercise number 6.6. Before start doing the problem from this exercise, let me give the introduction about this equation of the plane in the normal form. Let me take a 3D space here, x-axis, y-axis, z-axis. On the xyz plane, let me take a plane here. Take up a given point A on this plane. Let this point be at a distance of P from the origin here. And also let me take a normal vector, unit normal vector along this line. Unit normal vector n cap. Unit vector, its modulus is 1. N cap is 1. So let P be a capital P. P be an arbitrary point on this plane and AP is a line joining the two given points. So in this case, the equation of this plane in the normal form is given as vector R is R dot n cap is equal to P. What is vector R? Here the position vector of an arbitrary point P from the origin. And P is a distance between the origin to the given point A on the plane. And n cap is a normal unit normal vector along the line here OA. So therefore the equation of the plane in the normal form. The equation of the plane in the normal form. In the normal form. So using this equation, let me do the problem. See question number 1. Find a parametric form of vector equation of a plane which is at a distance of 7 units from the origin, having 3, -4, 5 as direction ratios of the normal to it. So here you have to find the vector equation of a plane which is at a distance of 7 units. Here it is at a distance of P units from the origin. So here P is 7. P is equal to 7 units. And the direction ratios of the normal vector is given. So therefore the normal vector n is here 3i minus 4j plus 5k. But what is an equation of a plane? Vector r dot n cap. We need the unit vector n cap. So you have to find the unit normal vector. So for that, let me find that unit vector formula is here n cap is equal to vector n divided by modulus vector n. So find modulus vector n. So square root of 3 square plus minus 4 squared plus 5 squared. So the value of this is 9 plus 16 plus 25 square root of 50, that is equal to 25 into 2. You can write square root of 25 is 5 root 2. Therefore our normal vector n cap is 3i vector n divided by modulus n. 3i minus 4j plus 5k vector k divided by 5 root 2. So you find vector equation of the plane in the normal form. They ask you in the normal form. So vector r dot n cap is equal to P. So what is vector r here? Just write vector r. Vector, they ask you to vector equation. So vector r dot n cap is, just now we got 3i minus 4j plus 5k divided by 5 root 2 is equal to, the value of P is 7 units. So this is the vector equation we are getting the equation in vector form. See question number 2. Find the direction cosines of the normal to the plane 12x plus 3y minus 4z equal to 65. Also find the non-parametric form of vector equation of a plane and the length of the perpendicular to the plane from the origin. See here they given the Cartesian form of the equation 12x plus 3y minus 4z equal to 65. Here they ask you 3 questions. First one is find the direction cosines of the normal and also non-parametric form of the vector equation of the plane. What is non-parametric? Either we represent in the dot product form or in the cross product form. This is your second question. Third, you have to find the perpendicular length of the perpendicular of the plane from the origin. First, let me take this Cartesian form of the equation 12x plus 3y minus 4z is equal to 65. So, this equation, first let me collect the normal vector. So, the normal vector here is 12i plus 3j minus 4k. So, here x, y, z is an arbitrary point, coordinates of the arbitrary point. So, normal vector. So, the direction ratios are, first you write 12 plus 3 minus 4. So, find its magnitude. So, the magnitude is, or I take that modulus of n vector is equal to square root of 12 squared 3 squared plus 3 square plus minus 4 square, that is equal to 144 plus 9 plus 16. If add, you will get square root of 169. What is the square root of 169? 13. So now we need to get direction cosines. Direction cosines. This is answer for the first question. Direction cosines is, so we divide the direction ratios by this magnitude modulus value. 12 by 13, comma 3 by 13 minus 4 by 13. Okay. Next question, you find the vector non-parametric form, vector equation of a plane in non-parametric form. So, we write the given equation in the Cartesian form as here. Just I write here, this is given equation 3y minus 4z is equal to 65. So, just write the dot product xi plus yj plus zk dot, write the normal vector 12i plus 3j minus 4k is equal to 65. What is this xi plus yj plus zk? It is an arbitrary point. Vector r dot 12i plus 3j minus 4k is equal to 65. See, actually we represent this vector r dot n cap. This is vector n only. Vector r dot n cap is equal to p. You have to represent in this form. So, for that, this is your n vector. So, n vector, we divide it by modulus n. Modulus n on both the sides. On both the sides. In that case, I will take the n cap here. So, this is given in the n vector form. Just let me write, this is n vector. I divide both sides by modulus n vector. So, vector r dot 12i plus 3j minus 4k divided by modulus n is 13 is equal to, what is this p, the right side here, 65 by 13. So the 65 by 13 is 65 by 13 is 5. So this is vector r dot 12i plus 3j minus 4k divided by 13. This is the answer for the second question. We represent the equation in the non-parametric form. And what is the value of P here? Answer for the third question. P is equal to here. I represent this in the form P. So P is equal to here 5. This is the answer. So the last question, they ask you the length of the perpendicular from the origin. Length of the perpendicular to the plane from the origin. SP is equal to 5. So we answered for the 3 questions. So just go through that. Thank you.